Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and today we're going to be starting Unit 3. So this is the notes for Unit 3, Lesson 1. Make sure you put your first and last name at the top right-hand corner of your paper, as long as the period and the date. So today's topic is multiplying, dividing, and simplifying polynomials. This should theoretically be a review of Algebra 1. So today's lesson might be easier than you thought it was going to be. How nice is that? All right, your objective for today is I will combine like terms, multiply and divide monomials, as well as multiply binomials. So let's talk about what polynomials, monomials, and binomials are. So a polynomial is an expression that has one or more terms. An expression that has one or more terms that includes, or we should say that can include, variables, numbers, constants, all that good stuff. That can include variables, constants, and coefficients, and all that good stuff. We'll just say etc. It can include a lot of things. So what's an example of a polynomial? An example of a polynomial is like x squared plus 2x plus 1. This polynomial has three terms. 1, 2, 3. Three different terms that are different, like they're not like terms. Another example of a polynomial could be 3, just the number 3, which is considered a constant. That polynomial has one term. Maybe you have a polynomial that looks like x to the 4th minus 7. That's a binomial, a polynomial with two terms. Maybe you have a polynomial that says x to the 5th minus 3x cubed plus 4x minus 1. So polynomials can look all kinds of ways. They're just expressions that have at least one term. They could have more than one term. And they can have as many terms as you want, essentially. A monomial is a polynomial of only one term. A polynomial with only one term. So for example, a monomial could look like 2x, or 3x to the 4th, or negative 1/2 x squared, or 4/7 x, or maybe just the number 7, maybe the number 0, maybe just the number 1. All of those are examples of monomials. There's a single term, a polynomial with only one term. A binomial, on the other hand, is a polynomial that has two terms. So a polynomial with only two terms, hence bi as the beginning of this word. So a polynomial with only two terms. So that could be like 2x plus 7, or maybe x squared minus 3x, or 47 plus x. Maybe x cubed over 3 minus 4, etc. So these are just examples of what a binomial could look like. There are always 1, 2 terms. 1, 2, 1, 2, 1, 2. Now, would the expression 3x minus 2x be a binomial or a monomial? Would it be a binomial or a monomial? Is this an expression with two terms or an expression with one term? So actually, this is a monomial because 3x and 2x are like terms. 3x minus 2x is simply 1x. This is a monomial because when you simplify it, you have an expression that only has one term. So you want to always make sure that your polynomials are written in the most simplified form that you can possibly get them in. Always combine your like terms and then figure out what type of polynomial it is after you've simplified your expression. One thing I just realized that I forgot to mention too is that the word roots of polynomials, poly means many. Nomials is kind of like the same thing as terms. So the word polynomial really just means many terms. Pretty neat, huh? I think word roots are pretty cool. So like binomial is 2 terms. Monomial is 1 term. All that good stuff. Just a little English lesson for you there in the middle of math. So here's our directions. We're going to take some monomials and we're going to multiply them by each other. This is where we should have a review of Algebra 1. So for example, we're going to take negative x times 5x. So when you multiply monomials, you want to multiply like parts. What I mean by that is we're multiplying negative x by 5x. You want to multiply the negative and the 5 and the x by the x. So negative times 5 would be negative 5. X times x would be x squared. So negative x times 5x is negative 5x squared. All right, now it's your turn. Multiply 2x by 3x. What do you get? So 2x times 3x would be the same thing as 2x times 3x, or 2 times 3 times x times x. 2 times 3 is 6. X times x is the same thing as x squared. And the reason why, and hopefully you remember this from your properties of exponents from Algebra 1, is when you multiply, you add the exponents. So x times x, this is really x to the first times x to the first. So this is the same thing as x to the 1 plus 1, or x squared. So your final answer should have been 6x squared. All right, part C, negative 90x cubed times 5x to the 5th. So negative 90x cubed times 5x to the 5th. So again, we're doing negative 90 times 5 times x cubed times x to the 5th. So negative 90 times 5 would be negative 450. And then x to the, when you multiply, you add exponents, so it would be 3 plus 5, or negative 450 x to the 8th. If you don't believe me, x to the 3rd times x to the 5th is really x times x times x, and then times 5 x's. Well, how many x's is that altogether? It's a total of 8 x's, so x to the 8th. So our final answer is negative 450 x to the 8th. Your turn. Multiply 10 x to the 20th y times x to the 3rd y to the 90th. Remember, you can rearrange it and write the like parts by each other. Make sure you have multiplication in between them. Go ahead and multiply, write your final answer. Give it a shot. So your final answer should have been 10x to the 23rd times y to the 91st. You can pause the video if you would like to check my work and just make sure that you did things correctly. Moving on. Now we're going to divide by a monomial. So let's start with y to the 5th divided by y to the 4th. So there are a couple ways that we can do this. I'm going to show you both ways. So the first way you can do this is you could write out y 5 times y times y times y times y times y. Y to the 5th is really y times itself 5 times, over y to the 4th, which is really y times itself 4 times. Well, I hope you recall that y divided by y is just 1. Y divided by y is just 1. Y divided by y is 1. And then one more. Y divided by y is 1. So what we end up being left with is 1 times 1 times 1 times 1 times y, which is just The other way you can do this, well, remember how when we multiply, we add exponents? When you divide, you subtract. So y to the 5th over y to the 4th is the same thing as y to the 5 minus 4. Well, what's 5 minus 4? 1. What's y to the 1st? Simply y. All right. So now it's your turn. Do x to the 6th over x to the 6th, or x to the 6th divided by x to the 6th. Go ahead and give it a shot. All right, so I did this using both methods. We get the same answer. So I wrote out x to the 6th divided by x to the 6th by writing x times itself 6 times in the denominator and the numerator. Well, x divided by itself is 1. I end up with 1 times itself 6 times. Well, that's just 1. So x to the 6th divided by itself is 1. Well, here I showed the same thing, but through subtracting the exponents. So x to the 6th minus x to the 6th, or sorry, x to the 6th minus 6 is x to the 0. Well, hopefully you remember that anything to the 0 power is always 1. That's just something that you need to have memorized, like a math fun fact that you need to have memorized for the rest of your life, basically. Anything to the 0 power is always 1. So we get 1 as our final answer. All right, part C. So now we're dividing a monomial by a monomial still, but we have multiple parts. So just like when you multiplied the like parts by each other with multiplication, in this case, you divide the like parts. So we divide the numbers and then the same variables by each other. So -6 over 10, and then x to the 5th, y to the 5th, x to the 6th, y to the 7th. So there's a couple ways we can go about this. Let me do method. Hopefully I have enough room here to do method 1. So x to the 5th is really x times itself 5 times. Y to the 5th is y times itself 5 times. And then x to the 6th. And then y to the 7th. Okay. So -6 over 10. Well, a negative divided by a positive is still a negative, so I'm going to keep that negative sign out front. 6 and 10 don't divide into each other perfectly, but they have a common multiple. 2 goes into 6 and 10. So what if I reduce 6 by 2? 6 divided by 2 becomes 3. 5 divided by 2 becomes 5. Sorry, 10 divided by 2 becomes 5. So we get 3/5. Now let's cross out all the things that cancel. So x divided by itself cancels 1, 2, 3, 4, 5 times. Y divides itself and cancels 1, 2, 3, 4, 5 times. We're left with 1x and 2 y's in the denominator. So we end up with -3 over 5. And that negative goes out in front of the whole fraction. The whole fraction is negative. So 3 over 5x, and y times y is y squared. So now let's do this using the second method. So the second method just involves subtracting your exponents. So -6 over 5, x to the 5th, y to the 5th, over x to the 6th. And then I don't know why I wrote that as a 5. That should be a 10. X to the 6th, y to the 7th. So again, divide the 6 and the 10 by 2, we get 3/5. Then we're going to have x to the 5th minus 6 and y to the 7th, or sorry, the 5th minus 7. And we get -3, x to the -1, y to the -2 over 5. Well, anytime you have a negative exponent, you need to make it positive. And the way you make it positive is you move it to the denominator or the numerator. So here they're negative in the numerator. I'm going to move the x and the y term, or the y part, sorry, those aren't terms, down to the denominator. And what happens is x to the -1 becomes positive. The exponent becomes positive when I move it to the denominator. Y to the -2 the exponent becomes positive when I move it to the denominator. And we got the exact same answer, doing it the other way. All right, so part D, 144x to the 5th, y to the 18th, divided by 14x to the 10th, y to the 7th. Go ahead and give this a shot on your own. All right, so the first thing that I noticed is that 144 and 14 are both even numbers, which means both of them can be divided by 2. So I divided 144 by 2 and got 72. I divided 14 by 2 and got 7. Then because I'm dividing, I have x to the 5th over x to the 7th. I know that I need to subtract those exponents. So I have x to the 5th minus 10. Then I did the same thing with y to the 18th and 7. So y to the 18th minus 7. So after I subtract those, I get 72, x to the negative 5th, y to the 11th, all over 7. Well, to make this exponent positive, because we never want a negative exponent in our final answer, I just moved it to the denominator. That makes the exponent positive. So I have 72 y to the 11th over 7x to the 5th as my final answer. All right, now let's talk about the next example. Here we are writing expressions in simplest form by combining like terms. So part A, we have 3x minus 8 plus 2y minus 3x plus 4y plus 10 minus 1. So like terms have to have the same variable to the same variable with the same exponent, and like constants have to be are like terms with other constants. So for example, this 3x is a like term with this 3x. So I'm going to underline both of them twice. Negative 8 is a like term, as it's a constant, so it's a like term with the other constants, which are 10 and negative 1. So I put a squiggly line underneath those. Then 2y is a like term with 4y. So I put one line underneath those. I like to put these like line things underneath my like terms because it helps me visually know which ones I need to combine and simplify. So let's go for it. 3x minus 3x is 0x. Negative 8 plus 10 minus 1. Let's see, negative 8 plus 10 is 2, minus 1 is just 1. 2y plus 4y is 6y. Well, 0 times x is just 0. 0 plus 1 is 1. And then when I write my final answer in as an expression, I always want to put my variables first, my constant last. So I'm going to put 6y plus 1, and that's my final answer. Now you try one, part B. So you have 3cd plus 4 minus 4cd plus cd minus 7 plus 3. I would underline your like terms in similar ways. Combine your like terms, write your answer as in simplest form. Go for it. So this expression ended up being 0 in simplest form. 3cd minus 4cd is negative 1cd. Negative 1cd plus 1cd is 0cd. 4 minus 7 is negative 3 plus 3 is 0. Well, 0 times cd is just 0. So 0 plus 0 is 0. The cd here technically has a coefficient of 1. Remember, whenever your coefficient is 1, you technically don't have to write that one. So that's how I knew that that was 1 cd. All right, let's do another one. So 2x squared plus y cubed minus x squared minus y cubed. So my like terms would be my x squared terms, and then my y cubed terms are like terms as well. So 2x squared minus x squared would just be 1x squared. Y cubed minus y cubed is 0y cubed. 1 times x squared is just x squared. 0y cubed is 0. X squared plus 0 is just x squared. All right, now you give it a try for part D. So I want you to add 2x squared plus x cubed minus x squared minus 2 plus 3x minus 5x plus 8 minus 9 plus x. Go ahead and give that one a shot. All right, so as you can see, I underlined my like terms in similar ways. Then as I combined my like terms, I just crossed them out so I knew that I had already used them. My final answer ended up being x cubed plus x squared minus x minus 3. So remember, for your final answer, when you write an expression, your leading term always needs to have the greatest exponent. So you always put the leading exponent, like the highest exponent first, the highest degree. Then you put the rest of the exponents in descending order until your constant is last. So here I have x cubed, then follows x squared, then follows x. There's technically an x to the first here, and then my constant 3, negative 3. All right. So for our last example, we're going to practice or review multiplying binomials. To do this, and then of course you need to write your final answer in simplest form. To do this, we're just going to do a whole bunch of distribution. So 4x plus 12 times 2x minus 3. What we do is we distribute 4x to the 2x and the negative 3, and we distribute the 12 to the 2x and the negative 3. So remember, distribution is just multiplication. 4x times 2x is 8x squared. 4x times negative 3 is negative 12x. 12 times 2x is 24x. And 12 times negative 3 is, I think it's negative 36. I'm pretty sure that's right. Okay. I know you're going to like send me a message in the chat if I'm wrong, but I'm pretty sure it's 36. All right, 8x squared minus 12x plus 24x minus 36. So we need to combine our like terms. And the only like terms are these x terms. So 8x squared is my leading term. Negative 12x plus 24x would be positive 12x. And then the negative 36 stays the same. And that's our final answer, 8x squared plus 12x minus 36. So now you give it a shot. X plus 2 squared. Well, some of you might say that this isn't a binomial times a binomial, but it is. X plus 2 squared really means x plus 2 times x plus 2. X plus 2 times x plus 2. Go ahead and multiply that. See what you get for your final answer. Give it a shot. So as you can see, I distributed the x to x plus 2, and I distributed the 2 to x plus 2. So x times x is x squared, x times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4. When I combine my like terms, these two terms in the middle, I get 4x. My final answer is x squared plus 4x plus 4. All right, do it again. Part C, x minus 6 times x plus 2. Remember, distribute the x to both terms and the negative 7 to both terms as well. Go for it. So when I multiplied these binomials, I got x squared plus 2x minus 7x minus 14. I combined my two middle terms because they were like terms. I got x squared minus 5x minus 14 for my final answer. Hopefully that matches yours. And our final example for today, 2x minus 7y squared. Remember, 2x minus 7y squared really means 2x minus 7y times itself. Go ahead and multiply that out and see if we get the same answer when you're done. So hopefully the 7y times the 2x didn't throw you off too much. When you multiply an x times y, you get xy. So what you should have gotten is 4x squared minus 14xy minus 14xy plus 49y squared. Combine your two like middle terms and you get 4x squared minus 28xy plus 49y squared. Whenever you have two terms that have the same degree, it's common to write your final answer like this. You always list alphabetically the first, so x, you would list x squared first, and then you put y squared second with everything else in the middle. All right, so now you need to do your extra practice. That's in today's Schoology folder. You're going to complete that, submit it. Send me a message in the chat when you're done letting me know so I can grade it real quick and give you some feedback before you leave class. After you're done with that, you're going to get started on your homework on Math Excel. I'll see you guys in class. Bye.